All right, middles, it's your turn. We are working with comparing fractions using visual models. Our problem says find two fractions that are equivalent to 2/3. We're going to do that by looking at our fraction strips. Remember, our fraction strips compare each fraction to the whole, and all of our fractions have a different denominator. So again, we are looking for two fractions that are equivalent to 2/3. What does it mean to be equivalent? Did you say equal? If you did, you're absolutely correct. So let's find our tiles that we need to build 2/3. How do we know where to find them? That's right, we use the denominator. The denominator in 2/3 is 3, so we're going to look at our 1/3 tiles. How many 1/3 tiles do we need to build 2/3? Well, if our numerator is 2, it tells us how many tiles we need. So we need 1/3, 2/3. Great job. Well, today I've added this nice little red line here because if we're looking for fractions that are equivalent to 2/3, it means that they should be the same length. So when we build our fractions, they should all hit our red line. Now, how am I going to go about figuring out which fractions are equal to 2/3? Well, I have a trick for you that I want to share today. In order to find equivalent fractions, we're going to use what we know about multiples. And we are going to look for multiples of the denominator. And so what was our denominator in 2/3? That's right, it was 3. So we are looking for multiples of 3. So that is the product when we multiply 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so on and so forth. So we're looking for those products, and those are going to tell us the multiples of 3. And what that does is it gives us the denominator that we should be looking for. So let's look at those multiples of 3. Do you know what they are? Well, can you count by threes? Let's do that together. 3, 6, 9, 12, 15. Exactly, you get the idea. Well, we're only looking for two fractions that are equivalent to 2/3, so we only need the next two multiples. So let's take a look at this list. 3, 6, 9, 12, 15. And this will give us plenty to work with. So we already have 2/3, which was our fraction with the denominator of 3. And so which fraction are we going to take a look at next? That's right, the one with the denominator of 6. And so that is our 6. We need to figure out how many 6 pieces are equivalent to 2/3. That means we're going to need to drag them over and count them out and see how many it takes to reach the line. Let's do that together. 1 6, 2 6, 3 6, 4 6. We're there. It takes 4 6 pieces in order to equal 2/3. So 4 6 is equivalent to 2/3. All right, well, the problem asked for two fractions that were equivalent. And so which fraction tiles are we going to use next? Did you say we're going to use the 9th tiles? That's right, because the next multiple of 3 is 9. So we're going to take 9th tiles and line them up and see how many we need in order to reach our line. Let's try that. 1/9, 2/9, 3/9, 4/9, 5/9, 6/9. It takes 6/9 to reach our line. Therefore, 2/3, 4 6, and 6/9 are all equivalent. Well, that's all our problem asked us to do. But do you think that you can use what you learned to figure out what the next equivalent fraction to 2/3 would be? Well, let's start with the denominator. What do you think the denominator of the next equivalent fraction is? Did you say 12? Absolutely, because it's the next on our list of multiples. Well, knowing that the denominator is 12, which set of fraction strips are we going to use? That's right, we'd use the 12s. Well, guys, I am seeing a pattern now. Everyone take a look at the fractions we've built so far. And specifically, I want you to take a look at the numerators. Do you see a pattern? There's definitely a pattern with the denominators. We know that the denominators were all multiples of 3 in order. Is there a pattern with the numerators? Did you notice that the numerators have a pattern counting by 2s? They are all multiples of 2. Therefore, the next fraction would be 8/12. Did you guess it? Great job, guys. That was a lot of work, but you did amazing. All right, senior scholars, here's your problem. Remember, this week we're using the area model to multiply numbers. Today and yesterday, we're multiplying a double digit by a single digit. Tomorrow, we're going to multiply some double digit numbers by other double digit numbers. So today, we're looking at 7 times 32. So that is our problem. All right, let's start with setting up our area model. Does anyone remember what we do first? That's right, we check to see if any of our numbers can be written in expanded form. And because we have a single digit and a double digit number, that means only one of them can be written in expanded form. And which number is that? That's right, it's the number 32. And so how do we write the number 32 in expanded form? Did you say 30 plus 2? If you did, you're absolutely correct. The 30 plus 2 is going to go on the top of our area model, and then our 7 is going to go on the side. Remember, the reason the area model works is because we are multiplying and coming up with partial products. Therefore, we are going to multiply our 30 plus 2 to our 7. And here's our little box that we're going to use to do that. So let's start with our first partial product. We have 7 times 30. What is 7 times 30? Well, if we want to do this quick mentally, we only need to know what 7 times 3 is. And what is 7 times 3? Did you say 21? If you did, you're absolutely correct. If 7 times 3 is 21, then that means that 7 times 30 is 210. Now, let's look at the next piece of our problem. We have 7 times 2. Well, what is 7 times 2? Super simple. 7 times 2 is 14. Now, because these were partial products, we need to put them together in order to get our solution. So we're going to add 210 plus 14. What is 210 plus 14? Did you say 224? If you did, you're absolutely correct. So because 210 plus 14 is 224, that tells us that 7 times 32 is also 224. Great job, senior scholars. Thank you so much for tuning in to Calendar Math with Miss Udo today. I'll see you tomorrow. Bye.